In this video, we are going to learn the process of constructing this population proportion for a given confidence interval. So, the problem goes like this. In a survey of 1,350 US adults, 754 said that they use the social media websites. Find a point estimate for the population proportion of the US adults who use social media and construct a 95% confidence interval for the population proportion of the United States adults who use social media. So it is a kind of lengthy problem. Alright, only you just have two numbers here. In fact, the total number of people surveyed is 1,350 and out of that 754 said yes. Right? This is the total and that is yes. And we are going to construct a confidence interval of 95% for this population proportion. Okay, so let us see what it is. I have the information up there. In order to find a point estimate for a population proportion, first I have to look for the sample proportion, right? That is denoted as p hat, in fact. And how do you find the sample proportion? Like this. It is p hat is equal to x over n, where x is the number of successes, n is the sample size, right? So in this problem here, you have this 754 people, they said yes. So that is a success out of 1,350. That's what it means. And q hat is opposite of p hat. This is a success, other one is a failure. And you get it by subtracting this p hat from 1. 1 minus p hat gives you q hat, right? And the formula that you have here to find the population proportion is p is lying between this left and right limit. So on the left side we have p hat minus e, and on the right side p hat plus e. And what is this e? This e is the margin of error which is obtained by doing ZC, that is the critical score for the given confidence interval. We will look at it in a minute. What is how do you get this Z value? That times the square root of p hat times q hat divided by n. N is that a sample there, right? So now once you find this population proportion, it says this: the probability that the confidence interval contains p is C. C means this is lower value, comma, higher value. Assuming that the estimation process is repeated over for a large number of times. Alright. Now, let us look at this piece. How are you going to get that? I have a separate table here in the next slide. Constructing a confidence interval for a population proportion. In step 1, we will identify, in fact, what is x and what is your n. And substitute those x and n values here. X over n gives you the point estimate p hat. And once you obtain this p hat, we have to verify and make sure that the product of the sample size times p hat is greater than or equal to 5. Similarly, the product of this sample size times this q hat has to be greater than 5. If this condition is satisfied, we will find the critical value for this Z that corresponds to the given level of confidence. In our case here, 95%. And we can use the chart, or the number will be given to us already. I'll show it in a minute. Now, find the margin of error. In step 5, what is the margin of error? That is E is equal to this thing. Z times square root of P hat times Q hat divided N. After finding that E, take it away from this proportion, right? I'll have to take it off, point estimate. In fact, I'm going to find the population proportion, in fact. So P minus E is less than P is less than P plus E. This is the final thing we are going to obtain. Okay. Now let us go back to the given problem. It is here. So let me first talk to you about this 95% confidence interval. So you have a normal distribution chart, and inside this whole shaded area contains 95% of the data. Alright, 95% of the data. So this side from 100, if I take away 95, there remains 5% of the data. Out of that 5% of the data, how much? 2.5% is on the left side and 2.5% is on the right hand side. And let me go to that value here. So in this graph, you can see the value is from negative 1.96 to positive 1.96. Those are the Z-scores that you have here, negative 1.96 to positive 1.96. The percentage contained within this is 0.95 in decimal form, which is equal to 95%. And what is this critical value for that? For the Z, it is 1.96, right? And I'm taking the positive value because you are going to have positive and negative values of this E. So always just take the critical value for Z as the positive value only. In fact, this ZC here, I got 1.96. Okay. And first step, I'm going to find my P hat. Like we saw here in this table, I'll have to find P hat, then verify this and come to this margin of error. This is Z, already I got it there. Okay, so let's go. So P hat is equal to, what is the X here? X is the successes, that is 754, and the total, that is N, is 1350. P hat is X over N, that is equal to 754 divided by 1350. That gives me P hat is equal to, let me go to the calculator, 754 have 754 divide 1350. See, that is equal to how much? 0.5585. Okay, so I will write 0.5585. So once you have your P hat, very easily you can find what is your Q hat also, right? Subtract. Q hat is equal to 1 minus P hat, that is 1 minus 0.5585. So what is that? On subtracting, you get Q hat is equal to 1 minus 0.5585. I'm just rounding it to the fourth decimal. It gave us 0.4415, right? So 0.4415. Now what is the next condition? I have to look for this. Find the product. N times P hat and N times Q hat must be greater than 5. Greater than or equal to 5. Okay, so let us multiply. First N times. Okay, so N times P hat. N is 1350 times P hat is what? 0.5585. And second one is N times Q hat. Q hat is 0.4415. Right? 0.4415. I think I already have it up there. See, 1350 times 0.5585 is 753.975. Rounding it to the nearest whole number is 754. And the next one is 1350 times 0.4415 gave us 0.596. So 754 and 596. 754, 596. 754 and this is 596. And you know 754, you have seen that already. 754 is that X value, right? And 1350 minus 754 gives you this 596, right? That's how we can go back and verify. The addition of these two numbers is again 1350. But here the condition is I have to just look for, is this number greater than 5? Yes, it is. This is also more than 5. Hence, I can go to my margin of error, this formula. I'll substitute my values in this. Now, you know, we already talked about the z-score, the critical value for z. At this point, it is 1.96 and 1.96, right? Okay, so I'll write down E is equal to 1.96 times square root of how much P hat, that is 0.5585 times 0.4415 divided by the N. What is that N? 1350. 1350. Like I always say, feel free to have the numbers in parentheses for clarity purpose. So let us enter these numbers in calculator. 1.96 times square root of, and I also have a division, I'll write it down. First number was how much? It was 0.5585, right? So on the top it is 0.5 or 0.5585, same thing, right? Times 0.4415, and underneath 1350, that number 1350, and that is giving me 0. How much? 0.026489, etc. Again, let us round it to the fourth decimal, that is 0.0265, right? 0.0265. So my E is equal to 0.0265. Double check, make sure 0265. Okay. Then the last step. In this, I'll have to substitute. And what do we call the left side? You know the left limit. We'll find the left end point and the right end point, that is P minus E, P plus E. And that is in between your population proportion. Right? This is the P, that is the P you are going to get in a minute. Alright, this is here. I'll just write down. P hat was how much? 0.5585 minus E value is 0.0265, and that is less than P, and the P is less than, again the same value, same P hat only, please, same number, 0.5585 plus, see on the left side we subtract, and on the right side you just have to add 0.0265. Let us go back to calculator again and do this. .5585 minus 0.0265, and that is giving me 0.532. Let us do the addition also. On adding, you get, what do you get? 0.585. 0.532, 0.585. So 0.532 is less than P, that is less than 0.585. It is 0.585, right? Let me write it down. .585, right? That is your final answer. This population proportion is between 0.532 and 0.585. As a statement, you can state it this way. with 95% confidence, we can say that the population proportion of the adults in the United States who use social media is in the interval of 0.532 to 0.585. And as a percentage, same thing, you can say it as multiply by 100 is 53.2 to 58.5%. That is the whole population proportion. That's all. Just do one thing at a time. Just identify what is your x, what is n, then the ratio, take it away from 1. And those are the two things you are using again and again. P hat and Q hat. See, this is P hat multiplied Q hat. And then you got again in this margin of error, ZC is given because of 95% confidence interval, you use this thing, right? Very easy, provided we know where to substitute what. And simplify carefully, you will get everything right. Okay? Thank you so much. That is 1350